So we're going to review the questions from the June 2014 Algebra 1 Regents, questions 13 through 24. Okay, so for this first question, 13 asks, which expression results in a rational number? So I would definitely look at each one of these numbers first and determine if they are rational or irrational. So the square root, and to check that, you can put it in the graphing calculator. So if you do second x squared 2, you can see you get a long decimal that has no pattern. So this one is going to be irrational. You can check for the next one as well. So we got 3 times the square root, or second x squared 3. Again, long decimal, no pattern. This is irrational. And I can check the next two in the graphing calculator, but we know that the square root of 16 is just 4, and the square root of 9 is just 3. So those are going to be rationals because they're just whole numbers. Okay, so for each one of these, we're going to be adding 2 of these. For number 1, we're going to get irrational plus irrational, which is not always rational. To check that one, we can always do second square root of 2 plus 3 square root of 3. And looking at that answer, it definitely does not give us a rational number. So this is irrational and not our answer. M plus n gave us irrational plus rational. And irrational plus rational is always irrational. N plus p gives us rational plus rational. And rational plus rational is always rational. So that is actually the one we want. And just to check the last one, p plus l will give us rational plus irrational, which is irrational. And just for you to have these rules when it comes to adding, it's rational plus rational equals rational, rational plus irrational, and irrational plus rational, same thing. This always equals irrational. And irrational plus irrational can be both. It just depends on the actual problem. So if you get irrational plus irrational, I would definitely check that in your graphing calculator. Okay, moving on to question 14. So question 14 is a system of equations. And to solve a system of equations, we have a few options. So one option is elimination. And in elimination, we're trying to eliminate a variable by making their coefficients equal. Another method we call substitution. And in substitution, we are solving for a variable and substituting. Okay, and in substitution, you're usually going to see a set of parentheses. So if you don't, then it's most likely elimination. And the last, that's hard to see, and the last is graphing, but we don't have to worry about graphing when it comes to questions like these. All right, and if we look at all these options, we don't see any parentheses, so there has been no substitution. So this is an elimination problem. So we're going to actually solve, or at least start to solve each answer choice using elimination so that we can see if it's the correct choice. Okay, so for number 1, I'm going to just recopy the original. So I'm going to recopy this every time. So 2x plus 2y equals 16, and 3x minus y equals 4. And now our goal here is to multiply or divide, if needed, each expression so that we get the expressions or the equations that we see in the answer choices. So let's start with the top one. Do we need to multiply by anything to get our first equation? No, because it's the exact same one. Now let's look at the bottom. For this one, we do need to do something, right? They're not the same. So let's multiply. What do we need to multiply this 3 by to get us 6? 2. So multiply by 2 and then distribute. We get 6x minus 2y equals 8. And does this match the second equation? No, right? So it's not 1. Okay, let's move on to 2. Now do the same thing. Recopy the original. 2x plus 2y equals 16. 3x minus y equals 4. And what do we... So look at the first one again. Do we need to do anything to the first equation to make them match? Nope, same thing. Look at the bottom. Yeah, we need to do something here. So how do we get from 3 to 6? We need to multiply by 2. And we actually just did that in the last one. We get 6x minus 2y equals 8. Does that match the second equation? Sure does. So our answer choice here is 2. Okay, question 15. The table below represents the function f. So which equation represents this function? So we're given the table. They want us to figure out what the actual equation of the function is. So the first thing that will be beneficial is to look at the rate of change. How is this changing? So from 3 to 4, it's plus 1. 4 to 6 is plus 2. 6 to 7 is plus 1. And 7 to 8 is plus 1. Great. 9 to 17 is plus 18. 17 to 65. I'm going to do this in the calculator and show you guys how to do it as well. You're just going to subtract the bigger from the smaller from the bigger. So 65 minus 17. So we get plus 48. 65 to 129, we get plus 64. And 129 to 257, we get plus 128. Okay, so we should not focus on the plus 2, so the 4 to 6 area, because the x rate changes. It's plus 2, right? So let's focus on the plus 1s first. So when x changes by 1 from 3 to 4, y changes by 18. When x changes by 1 from 6 to 7, y changes by 64. And because these are not equal, this 18 and 64, it cannot be linear. And since it's not linear, it can't be 4 and it can't be 2. Because those are linear equations. So that means it's going to be between 1 and 3. Now, both of these are exponential equations, but how do we choose between them? Well, we want to look at the difference or the rate of change between our y's now, right? So we got 18, 48, 64, 128. But this pattern here is special. This is what I notice at first. From 64 to 128, we're just essentially doubling, right? So if we do 64 times 2, we're going to get 128. So since that is doubling, we want a base of 2. And the only one that has a base of 2 is 3 right here. So our answer choice is going to be 3 because of that. It's harder to tell in the first half of the table because we skipped 5, right? But that tells us that our base needs to be 2. Okay, 16. John has 4 more nickels than dimes in his pocket. For a total of $1.25, which equation could be used to determine the number of dimes x in his pocket? Okay, so we need to define, no, they defined our variables for us. So which equation could be used to determine the number of dimes? So we know dimes, or x equals dimes, right? And John has 4 more nickels than dimes. So nickels is going to be x plus 4. And what is the worth of a dime? But 10 cents. So you're going to put 0.10. And for a nickel, it's going to be 0.05. Now looking at our answer choices, we want to look and see how inside the parentheses changed. So we could see in 3 and 4, they didn't add 4 more, they multiplied by 4 right here, right? So it's not 3 or 4. And in 1 and 2, we want to make sure that the correct coin is matched with the correct value. So we said dimes was x, so the x needs to be paired with the 0.10. And number 1, x is paired with 0.05, and a dime is not worth 5 cents. It is worth 10. So our answer is 2. The x is paired with the 0.10, and the x plus 4 is paired with the 0.05. Okay, question 17. If f of x equals 1/3 x plus 9, which statement is always true? So we're just going to have to substitute some values in and actually check these or think about it. So let's see. F of x is less than 0. So is that true? Is the function always going to be less than 0? To figure this out, we do something that we call, we're going to see if we can find like a counter, right? And the opposite, like a counterclaim almost. So when x is, let's say when x is 0. When x equals 0, we do 1/3 times 0 plus 9. We get 0 plus 9, and we get 9. So in this case, is the function less than 0? No, it's greater than 0. It's positive. So that is not always true. Okay, number 2. Is the function always going to be greater than 0 or positive? So let's see. Can we find a number that makes it 0 or less than? So we get 1/3. And now we want to pick something super negative and see if it's enough, right? So why don't we do, I don't know, negative 30 plus 9. And I choose 30 because it's easily divided by 3. So negative 30 times 1/3, or negative 30 divided by 3, we're going to get negative 10 plus 9, which equals negative 1. In this case, is the function positive? Absolutely not. Okay, number 3, if x is less than 0, is the function going to be less than 0? So let's see if we can pick a negative value for x and still get a positive value. Let's do something else easily divided by 3. Let's say x is negative 3. So we get 1/3 times negative 3 plus 9. 1/3 times negative 3 is simply negative 1. And negative 1 plus 9 equals 8. So we have a x value that's less than 0, but a function that is greater than 0. So it's not 3, so it has to be 4. If x is always greater than 0, the function will always be greater than 0. We could also look at this as a graph, which might be helpful. Let's do, so go to y equals 1 divided by 3, x plus 9. let's go to the graph. And it looks like we're not seeing the whole thing, but this is linear, so we know this graph is just going to continue going up in this pattern. And when x is greater than 0, we're in the first quadrant, we're to the right. And in this area, it is always above the x-axis, so yeah, it's going to always be positive. Our answer choice is 4. Okay, number 18. The Jameson family kept a log of the distance they traveled during a trip, as represented by the graph below. During which interval was their average speed the greatest? Okay, so you cannot simply rely on looking at the graph here. Sometimes the graphs can be a little deceiving. We actually are just going to find the rate of change between each interval, at least all the intervals they asked about, and then we'll do it from there. So it's saying from the first hour, so when x is 1 to the second hour. Now what is that rate of change? You have to do 110 minus 40 divided by 2 minus 1. So we're going to get 70 over 1, which is 70. Okay, now it wants the second hour. I'm just going to put the highlight below to the fourth hour. And we're going to do this again. 180 minus 110 divided by 4 minus 2. We're going, in this case, we're going to get 70 divided by 2. We're going to get 35. Okay, now they want the sixth hour to the eighth hour. So we're going to do 350 minus 230 divided by 8 minus 6. 350 minus 230, we're going to get 120 divided by 2, and we get 60. And last but not least, they want the 8th hour to the 10th hour. So we're going to get 390 minus 350 divided by 10 minus 8. So let's do 350 minus 390. 390 minus 350, we just get 40. Sorry, brain fart there, guys. 40 divided by 2, we get 20. So this is 20. Okay, so during which interval was their average speed the greatest? That's looking like 70, right? So from the first hour to the second hour. All right, and the reason I say you can't always trust the graphs is just looking at this graph, a lot of people might say from 6 to 8. It kind of looks steeper when you look at it, but it turns out 1 to 2 is actually steeper. Okay, 19. Christopher looked at his quiz score shown below for the first and second semester of his algebra class. Which statement about Christopher's performance is correct? Okay, so we have, he's looking at the interquartile range, the median, the mean, and the third quartile. So the first thing we need to do with both of these data sets then is to order them from smallest to greatest in increasing order. So I'm going to do semester 1 here. So we have 78 is the smallest, and then 83 and 88. I like to cross off as I go so I don't forget any. 91, 94. Okay, so that's semester 1. I'm going to do semester 2 down here, like a little lower, just so that we have space to do what we got to do. So now the smallest one here, 77. And then we go up to 80. And then 85. 88. 91, 92, 96. One thing I would do just to make sure you don't skip any numbers is count. So semester 1 should have 5 numbers, 1, 2, 3, 4, 5. Semester 2 should have 7 numbers, right? 7, 1, 2, 3, 4, 5, 6, 7. Perfect. So I didn't skip any. Okay, so the interquartile range. So let's go, the interquartile range is telling us that we need to find the quartiles. So we're going to do something and find the 5 statistical summary. That is basically just telling us we need to find the minimum, the first quartile, the median, the third quartile, and the maximum. Now the min, median, and maximum should sound very familiar, definitely. The minimum is just the smallest. So why don't I go ahead and color code these like I love to do. So the minimum for these is the smallest number. I'm going to skip to median. The median is the number in the middle. So we get 88 for this one, and we get 88 for this one, right? 88's in the middle for both of them. Okay, let's go on to the max. So we got 94, and we got 96. And now for our quartiles. So for the first quartile, we want to find the median of everything below the median, essentially. So for semester 1, 78 and 83 are below the median, because the median's 88, right? So let's find the median of 78 and 83. Well, there is nothing in the middle, so we're going to add them up, divide by 2, which is a great job for our calculator. So 78 plus 83 is 161, divided by 2, we're getting 80.5. Right, same thing for the semester 2. This one's a little easier though, because everything below the median is 77, 80, and 85, and this one does have a quartile 1, so this one is 80. Okay, let's repeat for the top, but now we're going to do the third quartile. And just in case anybody's wondering, I skipped quartile 2 because quartile 2 is the median. All right, quartile 3, again, everything above the median. So we got 94 and 91. So we're going to do 91 plus 94 divided by 2. Again, good job for our calculator. 91 plus 94 is 185. Divided by 2 is 92.5. Now find the quartiles up here. That's going to be 92. And now the interquartile range is very similar to something you may have heard before. It's kind of like the range, but it's the range of just the quartiles, right? So the interquartile range of the first semester is going to be 92.5 minus 80.5. So for the first semester, we get 12, which is the interquartile range, or the IQR. For the second semester, that one's a little easier to do. We also get 12. So now we can look at these answer choices a bit better. So it says the interquartile range for semester 1 is greater than the interquartile range for semester 2. And that is not true. They are equal. One is not greater. Number 2, the median score for semester 1 is greater than the median score for semester 2. Well, the median for semester 1 is 88, and the median for semester 2 is also 88. So again, one is not greater than the other. The mean score for semester 2 is greater than the mean score for semester 1. We have to calculate that. But if you look at option 4, that one looks a little easier. So I'm going to do that one first and see what happens. So the third quartile for semester 2, third quartile for semester 2 is 92, is greater than the third quartile for semester 1, which is 92.5. And 92 is not greater than 92.5, so it cannot be 4, meaning this should be 3. But why don't we just go ahead and be very, very sure. So the mean, we have to add all of them up and divide by the number of numbers. So for semester 1, we're going to do 78 plus 91 plus 88 plus 83 plus 94. At this point, I would press enter, and now you divide by however many numbers there are, in this case 5. So the mean here is 86.8. Now let's find the mean of semester 2. We gotta do 91 plus 96 plus 80 plus 77 plus 88 plus 85 plus 92. And now we're going to divide that by 7 this time, because there are 7 grades or numbers. We got 87. So it's saying the mean for semester 2 is greater than the mean for semester 1, and yeah, that's true. 87 is bigger than 86.8. So 3 is your answer. Okay, let's move on to question. We're on 20. Okay, so we have the graph of a function shown on the axes. Which point could be used to find f of 2? Well, remember, whatever goes inside these parentheses, it says up here, that's x, right? So this is x. So we want to look for where x is 2, and the only point that has a value where x is 2 is a. So A is going to be our answer. But just to show you, B has an x value of 0. C has an x value of -2. D has an x value of -1. A is the only one with an x value of 2. Okay, 21. A sunflower is 3 inches tall at week 0 and grows 2 inches each week. Which function shown below can be used to determine the height of the function of the sunflower in n weeks? So height is Fn and n is weeks. Okay, so looking at number 1, we have 2 times n, which is the weeks, plus 3. And it is saying at week 0, we start at 3 inches. So we should definitely have plus 3, and it's 2 inches per week. So 2n plus 3, yeah, it's definitely going to be 1. So since we know it's 1, we can get rid of 2 and 3. So now we just have to decide if it's 1 and 2 or if it's 1 and 3. Okay, so now let's look at number 2. So we know that at week 0 it has to be 3. So in this case, what we could just do is plug 0 in. We're going to get 2 times 0 plus 3 times 0 minus 1. And that's 0. 0 minus 1 is -1, and we get -3. So it's saying at week 0, the height of the sunflower is -3, which doesn't make sense. You can't have a negative height. So it's definitely not 2, which means it can't be 1, and our answer has to be 4. Right, but we can just check 3 just to make sure. So we have f of 0 minus 1 plus 2. Well, sorry, we don't actually have to even do 0 yet, because it's telling us that f of 0 is 3. So if we wanted to find f of 1, the next one, we would get f of 0 plus 2. We know f of 0 is 3. We get 5. So at week 1, we get 5. And that makes sense, because after another week, we should be increasing by 2. So 3 works. All right, 3 more. Question 22. The cell phone company charges $60 a month for up to 1 gigabyte of data. The cost of additional data is 5 cents per megabyte. If D represents the number of additional megabytes used, and C represents the total charges at the end of the month, which linear equation can be used to determine a user's monthly bill? Okay, so what is the constant? Like, what is going to be the fee that you are paying for this bill no matter what? It's going to be 60, right? So because it's 60, 60 needs to not be paired with a variable. It's paired with a variable here. And in 2, there is no constant even. That 60 is also paired with a variable. So it can't be 2 or 3. Okay? So we start with 60, as you can see in both of these. And they're going to charge 5 cents per extra megabyte. So since you're actually getting charged, you have to pay more. They're not going to subtract that from your bill. So they're not going to subtract, so it can't be 1. It's got to be 4. All right, 23. The formula for the volume of a cone is V equals 1/3 pi r squared h. The radius r of the cone may be expressed as... So this is asking us to actually solve. So they want us to solve for r. So they basically want r alone. So I like to rewrite it. And our goal here is to get r alone. So first and foremost, we should get rid of everything else. I usually like to start with the fraction, because a fraction just means division. So if we multiply both sides by 3, we're going to get 3v equals, the 3 and 1/3 is going to cancel out, and we're going to be left with pi r squared h. Still wanting r alone. And now so this is pi times r squared times h, and the opposite of times is division, so we're just going to divide both sides by pi times h. So we get 3v over pi times h equals, the pi's cancel out, the h's cancel out, and we get r squared. But r is not alone yet. It still has that exponent, so we need to take the square root of both sides, and we get r equals the square root of 3v divided by pi h. And that is number 1. All right, last question of the multiple choice. The diagrams below represent the first 3 terms of a sequence. Assuming the pattern continues, which formula determines an, the number of shaded squares in the nth term? Okay, so what they mean by the nth term, we're looking at these numbers down here. So this would be the 1th, or the first term, the second term, the third term, and we want to figure out how many boxes is shaded in each term. So in term 1, count them up. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. In term number 2, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's still 12, but just with this added 4 corners. So 12, 13, 14, 15, 16. So this one is 16. Meaning that term 3 is going to be 16, 17, 18, 19, 20. So it appears in each section, we're just adding 4 more. So we know our rate of change is going to be 4. And if you look at all your answer choices, yeah, all of them have 4n. So that, while we need it, it's not helpful yet. Okay, but now what are we starting with? What's our initial value or our y-intercept? Are we starting with 12 because, term 1 has 12? Well, no, because if that was true, you would get 16, right? I don't know why I put an equal sign there. Right, because you'd have to do 4 times the first term plus 12, you would get 16. That's actually what we have for term 2, but we need that for term 1. So 12 is not the right number. We actually need to figure out how many there are at term 0. And we know we're just adding 4 more each time, so term 0 is going to look like... Oh, that's a bad picture. Try to get artistic here now. 1, 2, 3, 1, 2, 3. It's going to look at that. Meaning there's going to be 1, 2, 3, 4, 5, 6, 7, 8. Or just 4 less than term 1. So it's actually going to be 2 because there is 8 shaded in term 0. Okay, and that is questions 13 through 24 on the June 2014 Regent.